Hi, I'm Francisco Campoy and this is Just for Funk. So welcome to episode number 35. Today we're going to build something quite useful, although completely useless if you think about it, because it's something that already comes with most OSs. It does come with Linux, but it does not come with Mac. So that's why I decided to write it for myself. Now, before we go into, but you could have installed something, yes, but this is not about how to do good engineering, it's how to learn how to program. So that's what we're going to be doing today. We're going to be programming a basic version of the command tree in Go. If you've never done that, don't worry, it's actually not that hard, but it's a good introduction on how to use file information, how to use stat, how to read directories, how to use links, and all these little things that are actually very useful, but very often we don't cover. So I decided to cover them today. Today is going to be a little bit of a special episode because I'm trying to record from home while not having the equipment with me correctly. So let's see how that goes. You might be able to hear some noises, just don't pay too much attention to those. Okay, so as always, I'm going to start with a completely empty directory, and the first thing I'm going to do is create my main package. Now, what we're going to do is I want to basically read all of the arguments that I receive on the tool, and then for every single one of them, visit it, whatever that means. But basically enter into the directory and either print all of the children if it's a directory, or if not, just print the name of the file where we are right now. And that's pretty much it. We're going to be using Recursion, that's for sure, but exactly what, it's not clear yet. So let's start by just reading the arguments first. So there's many ways of doing it. By default, what I want to say is rather than not doing anything if there's no parameters given, I want to do tree on the current directory. By the way, if you don't know what tree is, probably a quick demo would be nice. So if you do tree of go path, my little to-do tool, it will print all of these things, right? So it prints the directory and then the files inside, ignoring everything that is dot whatever. Because for instance, there's .git here, and that will not be appearing on our result. And then at the end, we also have 8 directories and 19 files. And I don't know if we will do that because it's not that interesting, but it's something that you can add at the end maybe. Okay, so what are we going to do? Well, we're going to say that the arguments I'm receiving are a list of strings that by default just has a dot. But if the length of the arguments is more than 1, then it means that we actually receive some arguments, so we're going to be using those instead. Cool. So let's just try whether that does what we expect. What? Okay. So let's run it. So if we do go run main.go in here, it says dot. So let's do go build -o tree. So if I do tree of dot, it says dot. Tree of foo says foo. Foo and bar says bar. So if I don't give anything, it's a dot. If I give anything, the dot is replaced by whatever I give. So that's the behavior I want. Cool. Okay, so the next step that we're going to be doing here is we're going to be iterating over every single one of those arguments, and let's just call it visit for now. So actually, let's call it tree, why not? So we're going to tree on that arg, and that could fail. If there is no nil, we'll do log printf tree this. So tree of the argument failed with that error. We're gonna need that, and we're not going to finish, we're just going to continue. Okay, so we're gonna create our func tree, given a path, returns an error. For now it doesn't do anything, it just prints the path and it finishes. So if we do tree, it says tree dot. Cool. And if you do full bar, should print full bar. Cool. So that looks pretty good. Now, what we want to do inside, though, is a little bit more complicated, because we don't just want to print the current path. We want to print the current path, and if it's a directory, we want to print all of the children below. And there's actually a tool that helps us a lot for this. Not really a tool, but it's actually part of the standard library. It's in the filepath directory. There's a walk function. So in the filepath directory, which is import path filepath, there's a walk thing, and the walk, basically you give it where you want to start, and then a function that will be called for every single child or descendant, actually any file that is accessible from that root. There's an example here. Basically what it does is for every single directory it prints stuff, and then it shows that there's this file skip there if you want to skip not only the current node but all of the children of that one. You do that. If you return nil, everything just works correctly, and you will do whatever you want it to do with the rest of the children too. And if you return an error, then you will actually handle it, and you'll receive it here. So if that error is the nil, then you'll do something about it. Probably just return it and print something. But anyway, with this, we have a pretty good idea of how to use it. The important thing is that it receives a walk function, and a walk function has these the signature here, receives the path, the file information, and a file information is actually something really interesting, because you can get it with os.Stat rather than open. You can do stat and get information about the file without really opening it, and you get the name, the size, the mode, the mod time, whether it's a directory or not, and then some underlying data source, which is not really interesting for us at this point. What we care about is the name, and also we care about whether it's a directory or not. The rest, I think we don't care about it, at least for now. So let's add that. So what we're going to do is we're going to do filepath.walk, and we're gonna pass the root, which is our path. Actually, let's change the name and call it that root, because we're also going to be receiving a function. Actually, I copied that. So okay, cool. So that's going to return an error. It's pretty okay. That way you can actually read the whole thing. So I actually prefer to call FI for file info, but that's personal taste for sure. Okay, so now what we can do is, just to try something, let's just print path and return nil, of course, because otherwise our function doesn't return anything. What is going on with you? Syntax, unexpected. Oh, close the parentheses. And oh, close those parentheses. Oh, okay, there you go. Cool. So now if we run this, what will we get? So go run main.go. Okay, so it prints dot, which is the current directory, and then 35 tree main and tree. Those are things that are inside. So that looks pretty good. What if we do go run main.go of my to-do directory that I showed before? Okay, so now you can see a bunch of things. First is that this is actually equivalent to the command find rather than tree. So this is not doing what we want, but maybe we can make it work. So we start with ///to-do, which is what we get here. And then we are printing the whole thing, which is what find does, but we actually want to print only the name. So let's change that. Let's say that we want to print only the name. And the easiest way is to get it from the file information. Also, if the error is not nil, we should simply return that error, because it means that something before failed and we don't want to continue really. Okay, so let's try it again. Okay, so now we have all of the files, right? But also we lost the information about how deep they were, so that's a little bit of a problem. We'll figure that out soon, but there's another problem which is even more important and easier to fix too, which is you can see that there's .get, and we said that we want to ignore anything that starts with a dot, so let's do that. So what I'm going to do is so if the first character of the name is a dot, then return nil. So if we do this, now let's see what happens. Okay, so the .get itself disappeared, but everything else still in there. All the descendants of .get are still there, which is not what we wanted to do. What's going on? Well, if you want to skip all of the things below, you need to return filepath.skip directory. That's a specific error that is not really an error. I'm not really sure I like this way of using errors, because this is not an error, really. This is part of the normal behavior, but whatever, it's how you do it. Okay, so now you can see that we get only the files that we wanted to get. So that's much better. Now, again, this is not what we want to print. We want to print the name. But now the part we're missing is the structure, right? Like we have a tree. This is not a tree. This is just a list of files, just the file name, not even what directories they are. There's ways to fix this. So for instance, you could do something like, let's think. You could get filepath.relative of the root to the current path. And then that is relative and error. If the error is not nil, let's return could not rel s to s, and this is why root to path and the error. I don't think why. Oh, maybe they're not related at all, like from different roots or something. That may be why. Okay, and then so now let's print that so you see what we're getting. Okay, so we're getting this. So actually, let me print only one of them, because otherwise it gets kind of confusing really quick. So you can see that we have server, which is directory, but also server/server.go. And then we have here, for instance, to do, static, lib, and angular main.js, right? So now what I can do is actually count how many slashes we get in there and use that as a depth. So let's try that. This is not the best solution, but just keep watching. In a minute, it will get better. So what we can do is filepath strings.split the relative path, and we're gonna separate it using the separator, which is a character, so we're gonna need to make that a string. And then once you split that, you're gonna get the length of that, and that's gonna be the depth. And then now what I'm going to do is we're going to print strings.repeat. We're gonna put 2 spaces and repeat that depth times, and then fi name, and that's gonna be printf. So what we're doing is basically dividing the names into components separated by the separator, which is that / in this case, / for Windows, at least until like Windows 10. I don't know, everything has changed, so no idea. But then so we're gonna get this is a 3, this is a 2, this is a 1, etc., and we're gonna use that as the depth. So if we run that again, cool. So now we see the structure, and we can see where these things are coming from, which is cool. But this is still not this, right? Like we're missing this part. And the problem is that in order to do that, you need extra information, because one of the things they need to do is to decide, for instance, this simple.go, what goes before it, you need to know that it is indeed one of the children of simple, not only the one of them, but actually the last one, and that this simple was the children of talk, which was in itself the child of to do, which it's something that maybe, just maybe, you can do with filepath.walk, but it doesn't seem like a very easy thing to do. So now we're going to drop this whole thing and do it in a completely different way that is actually easier. Okay, so I'm just going to delete the whole thing and start from scratch. So how we're going to do it? So what I'm going to do is, first of all, I'm going to read the, I'm going to do os.Stat. And os.Stat, what it does is it returns the file information for whatever we pass it. So we're gonna check, give me information about the root. And they're gonna give you a file information and an error. If the error is not nil, we should return error f could not stat this thing, and that is the error. So the root and the error. Otherwise, eventually we'll return nil. Okay, so file information is not used yet. That's fine. So now what we need to do is, first of all, we need to print the name. So let's print it now. So fi the name. What else do we need to do? Well, it depends on whether, so if it's a directory, if it's not a directory, then we're done. Because if it's a directory, if it's not a directory, there's nothing else to do below. So we're done and we just return nil. Otherwise, we're going to os read, no, ioutil read directory. There you go. And we're gonna pass the root, and that's gonna give us a bunch of file informations and an error. If there is no nil, again, could not read directory s, and this is the error, root and error. Otherwise, what we're going to do is we're going to iterate over the file informations, and for every single one of them, we need to know this amount of things. So we need to know whether the name starts with dot or not to decide what to print. But we'll decide that later. For now, let's do the simplest case, which is we just print everything. So what we're going to do is we're going to do tree of filepath.join of the root plus the name of this, and if error is not nil, then we're going to return the error. Okay, so now what we're doing is basically for every single child in the directory, we're going to call tree again. So let's see how that works. Okay, so we get back to the same version, basically, where we're just printing the name and we're getting all the files and directories. But it's actually not enough because we don't have any structure, right? But now the structure is much easier to add, because now what we actually can do is we can do a recursion, an actual recursion. So tree is going to be calling tree itself. So the information that tree is going to be receiving is where to start the tree, but also what is the context, like what happened before. And I'm going to call that indent for indentation. So let's say that I'm going to start with no indentation at all. And then we're going to pass indentation plus something that we add. And I'm going to say that the add for now is space. So by doing this, nothing happens, which is weird. Indent plus add. Let me think about this. Oh, because we're not using that at all. So let's use it here for now. So S. So we're going to use the indentation and the name. Okay, so now we get back the same structure, which is what we wanted to do. We want to ignore anything that starts with a dot. So if we could do it here, actually. No, because if if it starts with a dot in here at the root, that's not what we want to do. Let's do it at this level, because if I say I want to look at .get, that should work. But if I want to retrieve something that contains a .get, the .get should be ignored. So this is probably the best place to put it. So if fi.name of 0 is a dot, then continue. Okay, so now we're getting the structure that we want. We're just missing the lines correctly. But also we have, let me see. So yeah, we have the structure and we don't have any of the .get files. All of those have disappeared. Cool, so now to finish, the part that is actually the hardest one, which is how do you do those little arrows that look so cool? So that was like this. How do you do these cool arrows here? It's actually kind of complicated, but basically, let's think about this step by step. So if it's a file, actually, no matter what, if it's the if it's the last thing of a tree, the last element of a directory, the last file in a directory, whether it's a directory to itself or not, the last one has this corner here. Otherwise, it has this corner here, and if it's not aligned directly, so there's not, it's not a direct a direct child, but it's just a descendant, a child of a child or whatever, then you're gonna have these emptiness things here. Or even completely empty, and then this, right? So let's think about the easy ones first, which is if we have a directory, we need to add this. So I'm gonna say that add by default is actually this line. Actually gonna do it inside of the here. So if so we need to count if I equals len of +1. So if this is the last one, then we're gonna change add to something else. We're gonna change it to the one that has the little corner, which is that one there. Okay, so let's see what we did here. And I don't think this is gonna be working yet, but you get an idea of pretty much what is going on right now, right? Like we printing this, and then this works. This one though is wrong, because this one should show something here. And also, this was the last one, so we should have shown something different. So this seems relatively wrong, which is not great. Let's try to figure out how to fix this format. And there's the main thing that I'm going to change is the fact that rather than printing the identifier and the name in the same place, what I'm going to do is basically give so keep the information as up as possible, as high as possible. So what I'm going to do is print the whole context for the name before I get here. So right now this add here is what I'm going to be printed directly. So actually that should be a minus, not a plus. So if let's remove the add for now, and I'll explain what we're gonna do instead. But so here I'm going to do printf of the indentation plus that, and here we're gonna do the indentation plus this one here. And why do I do this? Actually, let me move this back so it compiles. So I'm doing this because that way we can actually see 1, 2, 3, 1, 2, 3. So okay, so we will print the position. So basically we're gonna print the whole thing until then we can start with the next tree. And for this to know what to print is actually you just need to know the indentation, right? And we have all of the information in here that we need to decide what indentation should be. So, okay, so now this is much better, but there's still a couple mistakes, right? One of them is those empty things. So for the to do at the end, what we should add is indeed empty. But in the other cases, this actually wrong. So if it's not the last one, it should be like this. But when it's the last one, then we move back to empty. That is not the line I thought it was. So let's run tree again to get it. This is the line 1, which is apparently a different character. Learning something. Yep, totally different character. Okay, so go run. There you go. So now this looks a little bit better. There's still one more mistake. You can see it right here. What do you think is going on there? It's actually because we have the dot get, and so it starts with a dot, and we ignore it. But we've already printed everything that goes out there. So the problem basically is that we printed this too early, so we should be here instead. Okay, so let's try that. Okay, so that is much better, but actually there's still a problem, which is what would happen if the dot get for any reason was at the end. We would actually print it wrong. So let's do a test. I'm going to create test.foo and test.bar, and if I do go run main.go of test, it will print test and nothing in there, which is probably what it's supposed to do. How can I come up with a better example for this? Okay, so according to this, before the dot, let's see, where's the dot? Dot. So dash, can we have a dash? Touch. Huh. Okay, so that is not the first one. So if we remove test za and test foo. Okay, so now I should be able to show the problem. Go run main.go of test. Boom. Okay, so now the problem you see is that dash ha is before our dot. So we look at this and we're like, oh, is there any other thing after this? And yeah, there is. But the problem is that those things will be removed later on. So we need to do the filtering a little bit earlier. So what I'm going to do is I'm going to create a list of strings. I'm going to come like this. And I'm going to iterate over all of the file system, the file informations. And if it's not a dot, then I'm going to do append names of name, and then remove this. And then also we're gonna need to iterate over the names instead. Name, and here we're gonna put a name too. Cool, so that works better. What about our to do? That looks very good. And if we do both, there you go. It prints the test and prints the do, and it prints everything in its place. Cool. Cool. So I hope that you learned a little bit how to use filepath.walk and filepath.split and strings.split and the separators and all of these things. These are things that are actually quite simple. There's not much magic behind it, but you can keep on improving this same program for quite a while. Like right now, are links working? Are soft links working? Hard links working? Are there soft links for Windows? What do you do in that case, right? So there's a lot of little things that you might need to work on if you want to make this an actual program that you can install around. I recommend doing it. It's actually fun. You will also learn more about how tree is implemented. There's something kind of cool, which is something I wanted to add, but the video is already too long, which is how to limit the depth. Let's say I want to get only up to 3 levels, right? But yeah, you could add that. You could add extra things like how to count how many files we have, which the program that I use here actually did. So if you wait a little bit, it should end up saying something useful. Hopefully, maybe it shouldn't have done it with that many files. Let's do it again with less files. So here you can see 8 directories and 19 files. How would you implement that? It's kind of a fun thing to learn. And it's also something that with filepath.walk would be easy to do. But again, filepath.walk limits you on what you can do. It's more like a find. So in order to build tree on top of that, either you have some really complex structure behind, or simply use a function that calls itself, just doing recursion. Cool. So as always, thanks for watching. Sorry for the delayed last episode. 2 weeks ago, there was no episode. It was because I was speaking at GopherCon Iceland, but right before that, I also was in Sweden. Right before that, I was at a wedding, and this weekend was my birthday. So it's been a lot of different things going on. But don't worry, just fun continues until for now, at least. So I hope you enjoyed the episode. Tell all of your friends about it, like it and retweet it and all of those things, and see you all in 2 weeks.
Hi, I'm Francesca. I'm Francesca Boy, and this is Just for Funk.